For this online lesson, I prepared 5 integration questions for you. These questions are for pure mathematics. Question 1. In question 1, I'm going to use the substitution technique here. And as you see, u is given. So we have to find du over dx, which is 2. Du over 2 becomes dx in this question. And for x in terms of u, it is going to be u plus 1 over 2. Let's substitute in the question. For x, we have to use u plus 1 over 2. And u is in the square root, under the square root. And dx is equal to du over d2. du over 2. So we have 1 over 4, 2 times 2 is 4, outside of the integration, and instead of u square root of u, I am going to use u to the power of 1 over 2. Let's expand that one. U times u to the power of 1 over 2 is u to the power of 3 over 2 plus u to the power of 1 over 2 du. And we have a basic integration here, add 1 to the power and divide by that number. Yes, that is going to be 1 over 4, 2 over 5, u to the power of 5 power 2, 2 over 3, u to the power of 3 over 2, plus c. And in place of u, I am going to substitute 2x minus 1. So 1 over 4, 2 over 5, 2x minus 1 to the power of 5 over 2, plus 2 over 3, 2x minus 1 to the power of 3 over 2, plus the integration constant is the answer for question 1. Let's take the picture of question 1 and carry on. Yes. Let's solve question 2. For question 2, to carry on with the integration, because we don't know how to integrate sine squared x, we have to use a trigonometric manipulation. Let's use cosine 2x, the identity for cosine 2x in terms of sine square x. Cosine 2x is equal to 1 minus 2 sine square x. So 2 sine square x is equal to 1 minus cosine 2x. So sine square x is equal to 1 over 2 times 1 minus cosine 2x, and substitute the equivalent of sine squared x there in the integration. So the question is going to be x times 1 over 2, 1 minus cosine 2x dx. Take this 1 over 2 outside of the integration because it's just a constant to multiply. X 1 minus cosine 2x dx. So here 1 over 2, let's expand that one. X minus x cosine 2x dx is the integration. Here we have two different types of integrations. We have only an x there, which is the simplest form of integration, and I'm going to separate that expression to be able to use integration by parts. So I am going to separate the integrations for two different cases. This is 2x dx. Let's call that one I. Say that this is I. So I is equal to x cosine 2x dx. And here we have to use what? Integration by parts, where u dv is equal to integration of u dv is equal to uv minus v du. So x is always u if you don't have ln x in the question, and cosine 2x is dv. So u is x, du dx is 1, du is equal to dx, dv is equal to cosine 2x dx. So to find v, we have to integrate both sides. Cosine 2x, integration of cosine 2x dx. v is equal to 1 over 2 sine 2x. So uv is going to be, u is x, v is 1 over 2 sine 2x minus v du 1 over 2 sine 2x dx. This is uv minus v du is equal to. So I is going to be 1 over 2x sine 2x minus 1 over 4 cosine 2x. Remember, you have to remember that integration of sine 2x is 1 over 2 minus 1 over 2 cosine 2x. So I is equal to 1 over 2x sine 2x plus 1 over 4 cosine 2x. And let's substitute I there. So 1 over 2 outside of the brackets. What is the integration of x? It is x squared over 2 minus I, where I is 1 over 2 x sine 2x plus 1 over 4 cosine 2x plus c as the integration constant. This is the answer for question 2. Let's take a picture for question 2, then carry on. Yes, let's solve question 3. Now it's time to solve question 3. And when you check question 3, it is easy to see that we have to use partial fractions to be able to do the integration. So first step is going to be to separate 20 over x squared minus x dx to partial fractions. So say that 20 over x squared minus x is equal to a over x minus 3 plus b over x plus 2, where x minus 3 and x plus 2 are factors of x squared minus x minus 6. So to equate the denominator, we have to multiply the first fraction by x plus 2 and the second fraction by x minus 3. Then say that 20 is equal to a times x plus 2 plus b x minus 3, because the denominators are equal. So we have to say that x is equal to minus 2 to get rid of a. 20 is equal to b times minus 2 minus 3, b is equal to minus 4. And say that x is equal to 3, then x is equal to 3, b cancels out. So 20 is equal to 8 times 3 plus 2. 20 is equal to 5a, a is equal to 4. So 20 over x squared minus x minus 6 is actually equal to 4 x minus 3 plus minus 4 x plus 2, or better, this is equal to 4 x minus 3 minus 4 x plus 2. Now in place of 20 over x squared minus x minus 6, I am going to write that expression and do the integration. Over x squared minus x minus 6 dx is equal to 4x minus 3, 4 over x minus 3 minus 4x plus 2 dx. And we have to remember that 1 over integration of 1 over ax plus b dx is equal to 1 over a ln ax plus b plus c. So by using that expression here, 4 ln 1 over 1 is 1, x minus 3 minus 4 ln x plus 2 plus c is the integration. And we can have a further simplification here. Take 4 outside of the brackets, and in the brackets we are going to have x minus 3, magnitude of x minus 3, and ln x plus 2 in magnitude signs, in modulus signs. We have ln's and subtraction, so we can write them as a single ln, as a division. So that's the answer for question 3. Take the picture of the solution. And carry on with question 4. Question 4. Cos cube x dx. We don't have any expression for cos cube x, so I am going to separate cos cube x to cos square x times cosine x. And I am going to solve this equation by substitution, and I am going to choose u is equal to sine x, y sine x, because when I take the derivative of sine x, it becomes cosine x, and we can also write cosine square x instead of sine x. So if u is sine x, du over dx becomes cosine x, du is cosine x dx, that part. And let's write cosine square x as in terms of sine x. Cosine square x is equal to 1 minus sine square x, cosine x dx. So let's substitute there. Let's write sine square x in terms of u. It is going to be 1 minus u squared, and cosine x dx, as you see, it is equal to du. So do the integration. Integration of 1 is u. Integration of u squared is u cubed over 3 plus c. So u is sine x. So the example is, so the answer is going to be sine x minus sine cube x over 3 plus c. Here in this question, it is important to separate cosine cube x to cosine square x to cosine x and choose a suitable u for the substitution process. And why I choose u as sine x? Because I know that derivative of sine x is cosine x. That's the way to use substitution method. Here you have to choose your own u. The variable, you have to choose your variable u as sine x so that you have to, so that du is going to be cosine x dx. That's the important part of the question. Again, picture of the solution. And let's solve question 5, the last example for today. And let's solve question 5, x squared ln x dx. Here we have a very important thing to be careful of. If in a question, as you see, we have to use by parts, method of by parts to solve this integration. But if in a question, if we have ln x, we have to change their places, and for an integration question, if we are going to use by parts, ln x is always u and the other expression is dv. Remember, for by parts, integration of u dv is equal to uv minus v du. And we use integration by parts also in example 2. But this is a different case because in the question we have ln x. If in the integration, if we have ln x and we are going to use by parts to solve the integration, u is always ln x because we only know derivative of ln x. We don't know the integration of ln x. So du over dx is 1 over x, du is equal to 1 over x dx. dv is equal to x squared dx. To be able to find the expression for v, we have to integrate dv. X squared is integration of dv is equal to integration of x squared dx. So v is equal to x cubed over 3. So u dv, integration of u dv is uv minus v du. U is ln x, v is x cubed over 3 minus x cubed over 3 for v, and du is 1 over x dx. Let's change their places to have a proper expression here. Let's take 1 over 3 outside of the integration. X cubed over x is x squared dx. And do the integration for that expression there. X cubed over 3 ln x minus 1 over 3 x cubed over 3 plus c. So the answer is x cubed over 3 ln x minus x cubed over 9 plus c is the answer for question 5. These are very important examples for integration for P4 for international A-level examination, mathematics examination. Also, you can use these examples for pure mathematics for A-level, Edexcel A-level examination. This is the end of the video. See you later.